È un grande piacere inaugurare questa, che ormai è la quinta edizione degli Spring Debates. Voi sentite l'eco?
No,
Io sento me stesso. Ok. Dicevo, è un appuntamento che nel corso degli anni è diventato identitario per il nostro dipartimento, che è il Dipartimento di Scienze Ecologiche e Biologiche dell'Università degli Studi della Tuscia. In particolare quest'anno abbiamo cambiato il format e incluso una prima parte dei seminari, chiesto ai colleghi e collaboratori nazionali e internazionali di dedicare un po' di tempo a raccontare la loro storia personale e professionale come una sorta di spunto per i giovani che ci seguono di quelle che sono poi le opzioni per percorrere questo tipo di carriera, per poi entrare negli argomenti scientifici di ciascuno degli speakers. Oggi è il primo di 8 appuntamenti, sarà in lingua inglese, ce ne saranno ancora 3 in lingua inglese e 4 in lingua italiana. Abbiamo 4 docenti del nostro dipartimento e 4 che sono i loro stretti collaboratori nazionali e internazionali. Ed oggi, come seminario inaugurale, abbiamo il professor Nicolò Colombani, che è un geologo dall'Università Politecnica delle Marche. Io lascio la parola alla collega Chiara Sbarbati di Nicolò, che lo presenterà prima appunto di entrarci nel suo seminario. Quindi per ora, tanto vi ringrazio a chi è già online e fate domande, mi raccomando, se siete interessati, questa è un'occasione live che poi in differita non avete, quindi osservazioni, contributi sono ben accolti e buon seminario a tutti.
Grazie a Giovanni e ringrazio nuovamente anche Nicolò per aver accettato di partecipare a questi seminari. Nicolò, appunto, Colombani è professore associato presso l'Università Politecnica delle Marche, è un geologo e più specificatamente un idrogeologo come me, quindi si occupa di tematiche riguardanti le acque sotterranee in generale nelle loro diverse sfaccettature e insieme condividiamo un progetto PRIN che, insomma, per chi magari sente per la prima volta questo acronimo, sono dei progetti di ricerca di rilevante interesse nazionale e appunto in questo seminario Nicolò presenterà parte dei risultati che abbiamo ottenuto in questo progetto che si configura proprio come un progetto molto multidisciplinare, quindi anche adatto all'audience dei nostri dottorandi della scuola di dottorato, proprio anche perché tratta alcuni magari non specificatamente il seminario, ma tutto il progetto, anche alcuni aspetti legati appunto all'ecologia. E quindi non rubo altro tempo e passo la parola direttamente a Nicolò.
grazie Chiara. Buongiorno a tutti, quindi grazie della presentazione. Avevamo detto che facevo un piccolo excursus di alcuni minuti, non troppo, sulla mia carriera accademica per capire un attimo diciamo, le possibili evoluzioni di futuri studenti o di studenti di dottorato. Se non vi dispiace, from now on I will speak in English, otherwise it would be confusing for the non-native speakers. So I present myself once again. Nicolò Colombani. I graduated in Ferrara University, university located in northern Italy, in 2002, so quite a long time ago, in geology. And essentially, after this, I had the opportunity to work with some European project as a fellowships. So before to take any PhD, this was a hard training for me, but it was a very challenging opportunity. And then after this European project has been finished, I applied for a PhD position in Roma La Sapienza, and I terminated this essentially in 2011 in hydrogeology. And then, since I was not convinced of what to do exactly, I also take another PhD in geochemistry in Bologna University, terminated in 2015. So after that, I spent again my career as a non-permanent position, as most of my colleague has experienced in the last 20 years, because I must tell you that I'm quite old, so I'm nearly half a century. So I have been, let's say, many years spending my postdoc as a non-permanent position in various universities, collaborating in any case with different discipline and different professors, like, for example, the ecology professor in Ferrara or geochemistry professor, both in Bologna and in Ferrara once again. And finally, I landed down in Ancona, essentially in 2018 as a researcher. Researcher type A for the people that are, again, quite old and understand what would be this mean, because now researcher type A are not anymore a kind of researcher available position, because actually there is a tenure track researcher only position. And then after research type A, I did 3 years for research type B, again in Ancona, and finally I became associate professor. I'm actually teaching applied hydrogeology in a course taught in English and hydrogeological risk for environmental engineering course in Ancona. So this is more or less my, let's say, non-linear, I would say, highly non-linear career development. And well, now I will share my screen. So I will start my presentation. So I ask also Chiara or the other advise me.
Vediamo bene, Nicolò. We see you.
Okay. Nice to hear. So once again, I coming from the CIMAO department. So it's once again a multidisciplinary department, because it's the Department of Science, Engineering of matters and environment, and also urban science. So many skills are involved in this department, as many departments nowadays in Italy. Today I will speak about this hopefully interesting for you no excess project. Is a print project financed by the Moore. And it is coordinated by Elisa Soana from University of Ferrara. She is an ecologist, and I am whatever. I can be an hydrogeologist or geochemistry or hydrogeochemistry level. And Chiara, that is, again, hydrogeologist. And these are the 3 universities involved. So Ferrara University, Tuscia University, and Politecnica delle Marche. Today I will speak about the salinity origin and pattern in shallow groundwater bodies of the Po River lowland. Why I will tell you about this? Because this is a kind of a, let's say, typical example that we may find all over the world. For example, we may say that the famous delta is the Nile Delta, but is also the Yellow River Delta or the Pearl River Delta in China, as well as there are many other examples in Florida or even in Netherlands that resemble what we found in this lowland and delta environment. So, first of all, I'm a geologist, so let's have a look at what happened in the past. Would say from a geological point of view, very recent past, during the Holocene, that is the maximum extension of the Adriatic Sea, that is comprising the whole area of the Po Delta lowland. What does it mean? That essentially we may have still a remnant of paleo seawater intrusion trapped in inland coastal environment. More specifically, now we can see the modern Po Delta that has been evolved from the Po di Primaro to the actual Po River branch in the last 2000 years. This means that we have a kind of an entanglement in between marine environment, back barrier, wetlands, palustrin, or primary river sedimentation. And it's also important for hydrogeologists. Why? Because if we have river-derived or palustrin-derived sediment, most probably we also have the groundwater, that would be fresh water, while if we have back barrier or shallow marine sediment, they could host, for example, brine or salt water. This is especially important. Why? Because as you will see in the next slide, most of this territory is devoted to agriculture. You can also see from this aerial picture that essentially it is almost all cultivated. And let's say the cultivation in this kind of reclaimed environment is quite challenging nowadays. Why? Because of the salinity of the soil. So most of the area here depicted from the northern Adriatic Sea and this back barrier wetland is below the actual sea level. So there is a huge drainage network that is actually removing the water from this part of the land to keep the land dry and allow people to stay there and to cultivate. But this is also triggering salinization of the sediment. Why? Because we have seawater trapped below this land that is migrating upward. Okay, let's have a look to strictly the data we have. We move a little bit early before of this spring, essentially in, let's say, 10 years ago, we started this monitoring using monitoring well provided by the Emilia-Romagna region in the coastal aquifer. And we found out this graph for non-specialists is just a graph showing the TDS, total dissolved solids, so essentially the salinity and the chloride content versus chloride plus bicarbonate. Why? Because this graph provides us an idea of the source of salinization. For example, if your sample are following precipitation dominance, this is the main source of salinization, while if they are falling in the middle part of the graph, they are essentially due to water-rock interaction, so dissolution of mineral from the rain, or they may fall into the evaporation dominance. As you can understand, most of these samples are in the evaporation dominance. And the same is applied for this other graph that is depicting sodium and potassium instead of chloride. So I move this away. Okay, it's better. To really grasp what was the origin of the salinization, we depicted two typical environmental tracer, bromide and chloride. Why? Because these tracer or water constituent that you can find in any water sample do not interact with rock because they cannot be sorbed, they cannot be even used by bacteria, so they are not involved in any biogeochemical reaction. And if you plot them, for example, against the Po River water, so a member of the fresh water, and the actual sea, Adriatic Sea water sample, you can see that they plot on a different line respect to our groundwater sample. So we were speculating, okay, there must be a little bit different origin of the salinity respect to the classical seawater intrusion mechanism. The classical seawater intrusion mechanism is just plain that the seawater is migrating through the aquifer because the elevation of the seawater is higher than the elevation of the groundwater here. And this is true because actually we have the ground elevation that is lower than the average sea elevation. So there is a migration effectively through these media, but this migration is very, very slow. Okay, so most of the sample that we can catch, maybe 15 kilometers inland, are not resembling an actual seawater intrusion, while probably they are resembling a very old seawater intrusion. So how can we define if this water is contemporary, for example, the last 50 years, or is very old, we can use, for example, the radiocarbon dating that is useful to understand the sediment age. But the sediment age is not the same to state the water age. Probably the water has been flushed many times since the sediment has been deposited. We can see, for example, that we are with this sediment along this transect with 5,000, 6,000 years before present. This means BP before present. And the oldest year are 10,000 or even 20,000 years before present. But these are the sediment and not the water once again. So plotting the molar ratio among chloride and bromide is again depicting a different situation respect to simple mixing between the Po River branches water and the actual seawater. You can see that all of the sample are aligning, like using an asymptotic content, about 900 instead of the classical 600 ratio number for the seawater. So once again, we know that there is something we don't understand respect to the classical seawater intrusion mechanism, but once again, we need to focus more in depth on how this is working. And this is how we have done. We collected many samples in a single well, okay, to depict the vertical variation of salinity. You can see here well number 5, P5, which is not saline for most of the column, and then it's becoming saline. And then we have P34, that is mildly saline or brackish from the beginning, and then is becoming hypersaline. Why? Because the Adriatic salt content is about 35 grams per liter, even less. And here we go about to 80 grams per liter. So we have a huge amount of salt. And this is another hint that something is not working if we think that is the aqua seawater that is intruding, and that's all. But we have done a little bit more, because we have also analyzed the tritium content in water. Tritium is a radioactive decay isotope, and the half-life of tritium is about 12.6 years. Okay, so whenever we know the concentration of tritium in the atmosphere, we may even speculate if we found the same concentration or lower concentration about the age of the groundwater we are sampling. And whenever we can sample at a very high resolution vertically, we can even, you can see here, depict the classical decrease or concentration gradient that we may have in an aquifer. So let's have a look what is the actual tritium concentration in tritium unit. This is the unit expressed for tritium. You can see that after the 60s, we have a huge peak. This is a log scale vertical axis of more than 1,000 tritium unit. Why? Because of the atmospheric testing of nuclear bombs. Then US and Russia stop it, and we have a decline. And actually, well, not actually, at the time we sampled these wells, we were about 5 tritium unit with fluctuation among season. And effectively, we may see that the average concentration for the non-saline water in P5 is about 5 tritium unit. But what about if we found 2.5, like in this sample here? It means that probably, since it is half of the actual concentration in the air, the groundwater sample here has 12.6 here. And what about this? It's much lower, because we are reaching the analytical resolution of our instrument. So this water is very old. And what about the P34? only the 3 sample in the upper part, the brackish one, are contemporary water, and then we have a decrease, and after 8 meter below ground level, we have very, very old groundwater, which is almost coincident with the very, very high salinity of this water. So it means that this is not actual seawater intrusion, but is a remnant of, for example, a paleosaline environment where we have a kind of a subca environment where everything was evaporating and a crust of salt was remaining in the end. But then going a little bit at a larger scale, how can we manage this problem? Because now we know that the salinity origin is not only from the actual Adriatic Sea water intrusion, but also from upconing of this very highly saline water from the base of the aquifer, which is storing a lot of salt. One of the idea is using numerical modeling. We have employed one of the state-of-the-art of density-dependent numerical flow and transfer model, which is called CWAT, developed by the USGS, or Geological Survey of the United States. And this model encompasses all of the rivers with their river level, all of the drainage channels that are present, a huge network of drainage channel, as you can see, and their reclamation effect, like removing water, and also constant heads, so constant water level and salinity for the Adriatic Sea here, Valli di Comacchio, or Vene di Bellocchio, Valli Bertuzzi, Lago delle Nazioni, and all of the surface water bodies that are present in this domain, which is the aquifer or coastal aquifer of the Ferrara province. The numerical model needs also the three-dimensional representation of the hydraulic conductivity of the sediment. Why? Because if the sediment is non-permeable, then the water is not moving. So in blue, you can see non-permeable sediment at the base of the aquifer, while whenever we have sandy sediment, we will have very high permeability and very high mobile water. Whenever we have silt or muddy sediment, we will have an intermediate water movement, and the model can calculate, okay, the quantity of groundwater that is moving from one point to another, and also the velocity of groundwater filtration, and also the salinity of this groundwater. So, first of all, we have built up this model and calibrated versus real observation. These are heads or water level in different piezometers in the area. And the model is resembling the real behavior, not perfectly, because the model is never reaching the complexity of the nature. Anyway, we can state that our model can mimic or replicate nicely the observed heads and also the observed salinities. So our model is mimicking the salinity pattern not only on the horizontal spatial resolution, but also vertically. And from here, we can see that the salinity is not always increasing, not always decreasing, but there are zones where the salinity is decreasing over time. This is the last 10 years, for example. Places where salinity is almost stable, or places where salinity is rising up, like the P10. And this is very useful. Why? Because the model can be used to understand what is going on actually and what will happen in the near future. So if you need to manage water resources, this is pivotal because you would have a kind of a instrument that provide you some future responses. And again, you can calculate, for example, the classical water balance. So you know the evapotranspiration component, how much the plants are removing from the aquifer. What is, for example, the water flow from the aquifer to the drainage channel, and whenever it is increasing or it is decreasing, what is the water exchange in between rivers and the aquifer? As you can see, much less than the aquifer, let's say, into the drainage channel, or how much water is exchanged among surface water and the aquifer, like brackish and saline water bodies, or the aquifer into brackish and saline water bodies. Also, it can compute the overall mass of salt present in the aquifer whenever it is increasing or decreasing, and the concentration, the average concentration in the aquifer. Moreover, if you don't know exactly, for example, if the plants are absorbing salt or excluding salt, because there are type of plants that for, let's say, mechanism of defense, they simply exclude from the roots the salt, other they accumulate salt, so they remove it from groundwater. This is a source of error in our model. So our model is nice, but it's not perfect. And we need to know, for example, better which kind of plants or type of crops essentially are present or have been present in the model domain to better understand what is the real mass of salt present in the aquifer whenever it is increasing or decreasing in the future time. Okay, just to show you some of the results, this is a small area here respect to the large model I show you, and this crop is just a line between the sea, Adriatic Sea, and the Comacchio Lagoon, and this is what happened, for example, if we make it working, in 2 years of simulation, and as you can see, there is not huge changes because the aquifer is not extremely permeable, and we have this blue belt, which is the actual dune belt, which is storing recharge water or precipitation water, the blue, only almost non-saline, and all of the rest is about 30-35 grams per liter. If we run it again, you can see that in some period, evapoconcentration of plants, so the evapotranspiration of some plants or simply evaporation in summer, create a little bit higher salinity than the actual seawater, but this is not really a game changer, let's say, in this area. In any case, you can visualize what is going on below our feet, which is not trivial, for instance. Okay, let's move further. Now we are looking exactly to the results we have obtained, part of the result we have obtained during this project that was focused on nitrogen speciation and nitrogen, for example, leaching into groundwater or nitrogen removal in surface water in saline and non-saline environment. We selected a site that was both a portion was not extremely saline and another portion was extremely saline. Here is depicted the groundwater flow direction, and in this triangular portion, the salinity of the soil was so high that the soybean that the owner was growing up here were almost gone due to salinity. So the owner said, okay, I can rent you the field to understand why I have lost this let's say, field and not this one. So we have installed instrumentation here and here to grasp the differences. The highlight of the first paper, whenever you like to see, for example, more hints or detail about what I'm describing here, you just copy and paste this DOI or digital object identifier, and you will be diverted or reverted into the paper that is actually open access, so you can download the paper and read the highlights or conclusion or the whole paper itself. Clearly a technical paper. Anyway, we found in this preliminary study that the salinity of the soil was extremely elevated, even 30 grams per liter, 1 meter below ground. Okay, so here we have once again sample with a technique used called multi-level sampling technique every 20 centimeter to understand the vertical variation of salinity. And then we applied statistical description like a principal component analysis, which stressed the strong connection among trace element and saline PT horizon. So we found a clear connection among the buried PT horizon and the accumulation of some trace element that are arsenic, for example, or aluminum, as we can see, we will see later on. Also, we found out that PT aquithards are the major saline source in this reclaimed land. So, whenever we see before very highly saline groundwater, then we also have to look for PT layers, because maybe these PT layers are accumulating saline sources. Finally, plant tissue fragments, we stated that can act as a long-term source of diffusion-driven salinization. Why? Because they store a lot of salt and then they can release it slowly by slowly. But this means that your field, practically, if you are a farmer, will remain saline for a lot of time, even if you flush it with a lot of fresh water. Okay, what is the main result? Once again, we analyze what? Chloride and bromide. Why? Because they are tracer. And then it's easier to understand the fate and transport of water, the water molecule, without any biochemical reaction. This horizontal line is the line depicting the level of the tile drains. And these are graph the concentration above chloride in milligrams per liter and below bromide in milligram per liter for pore water or leaching fraction and plant available water. As you can see, the plant available water is always higher than the leaching fraction. Why? Because plant can remove not only the water that is drained down by gravity, but also the water that is attached to the molecule of soil or particle of soil. And this high salinity usually is the one that create then problem to non-tolerant species like soybean. We also analyze dissolved organic carbon, the fraction of organic carbon, labile organic carbon, respect to non-labile organic carbon, to understand what could be the reactivity of this sediment. And again, leachable fraction and plant available water fraction. Not only DOC and its reactivity, but also ammonium and nitrate. Why? Because ammonium and nitrate are the major problem in this lowland, because of they are nutrient and they can cause eutrophication if there is an excess of these two components into surface water. As you can see, the component of nitrate available from the plants is extremely elevated in the unsaturated zone or above the tile drain, while in saturated condition we have prevalence of ammonium. Once again, this nitrogen can be due to fertilizer application or can be due to combination of fertilizer and presence of organic nitrogen into the PT sediment that then is mineralized into nitrate in presence of oxygen or in ammonium in reducing condition. So a very complicated matter. Anyway, the fate and transport of nitrate and ammonium in surface water has been analyzed by our colleague of the Ferrara University, and they have already published some nice paper about that, and also some technique to diminish this reactive nitrogen load to surface water. While I told you we are hydrogeologists, so we look behind our feet, and we were looking also to the geochemistry, because, for example, we may have aluminium, silica, or chromium, or arsenic that are leached or can be leached by this kind of sediment. And we found once again that the plant available fraction was elevated higher than the leachable fraction. For some element like aluminium was sometimes extremely elevated. That could also be toxic for some specific plant. So we were saying, okay, it must be due to some reason. And then we analyze this reason into the lab, because it's not possible to understand anything in the field whenever you are sampling an open lab. So you take sample into the lab, and finally our aim was to understand whenever the plant residues in peat can store and release salts and heavy metal into pore water, or whenever the plant available salinity is higher than the leachable fraction. How we have done? We have used the technique called flow interruption experiment. So we have collected a core, a small log of sediment. We have put this log into column into the lab in a well controlled environment, and we use synthetic rainwater reservoir, and we pump this water into the sediment, and we have collected and analyzed water sample in the outflow. The highlight of this specific research are that flow interruption in column were assessed via analysis of trace element, and they state that the mobility is quite elevated in this salinized PT aquitard. Then we have used sequential extraction, so we analyze not the water phase, but the solid phase. And using a sequential extraction technique, we quantify the limited extent of pyrite oxidation. We will see in brief what it means. Also, flow interruption shows that peaks of arsenic, manganese, lead, and nickel can be easily achieved and easily exceeding the WHO standard. Finally, irrigation period after prolonged drought could trigger trace element mobility. This is the core of our paper, that once again can be reached just pasting this digital object identifier. What about pyrite? Pyrite can be present into the PT layers because bacteria are ubiquitous, and in reducing environment, they may create this biogenic pyrite, but this biogenic pyrite can also be essentially reoxidized into what? Sulfate, iron hydroxide, and acidity. So it can acidify your water, and this is one of the potential explanation of the aluminum content, very high aluminum content, because the solubility of aluminum is only possible in acidic environment. Aluminum is not soluble in basic or neutral environment. So to achieve this, we use this trace element sequential extraction procedure modified by a paper of Chiara. Essentially, you can treat the sediment with salt, chloride, magnesium chloride, or with weak acid, or with stronger acid, to extract a target phase. For example, the exchangeable trace element that could be loosely bound to our, for example, amorphous iron hydroxide, or extract trace element into the amorphous hydroxide, trace element in crystalline iron hydroxide, so more recalcitrant, more resistant, and finally, trace element bearing sulfides, so into very reducing sulfide like pyrite. And these are two different flow experiments that we have run with two different columns. Why? Because whenever you collect one sample here and one sample 10 centimeter nearby, you will have different results. The interesting thing is that probably is not easy to see, but whenever the TDS was decreasing, we stop the flow and we have a peak. And then the TDS, once we resume the flow, was decreasing. And then we stop the flow and this was increasing. And this is also applied to the oxygen reduction potential and the pH. So the pH was acidifying. Okay. And what about the sulfate? Sulfate were released and also iron. And this is why we were postulating of the pyrite oxidation. But pyrite is not only containing iron and sulfur, it can also contain arsenic or other heavy metal, because nature is not perfect. And then pyrite can be arsenopyrite or can be complemented by many vicariant elements. So this is why we have analyzed also all the other elements like nickel, silica, arsenic, and so on. Finally, we have done another experiment, like what about instead of rainwater, we flush the column with salt water, with saline water that is coming from below. And then we discover, for example, that we may have a little bit of release of, again, aluminum, and especially for lead, there was somehow some release, and also arsenic, because this is in milligram per liter, so arsenic was peaking up to 20 microgram per liter, that is two times the actual limit of WHO. What about the results from our sequential extraction? You can see pre-experiment and post-experiment for arsenic. Arsenic into the sediment was present in pre-experiment all into iron sulfide, so pyrite. Then pyrite was oxidized, so pyrite decreased, and also arsenic content decreased in the post-experiment sequential extraction. And then it increased where? Into the crystalline iron oxide. So we effectively have a shift, okay, of arsenic from one side to another. And this is also explaining a little bit the mobility of arsenic that was found also in the water out of the column. The same apply for nickel, and a little bit less clear for lead and other like aluminum. But iron is clear that whenever it was more present in pre-experiment into iron sulfide, then was present more in crystalline iron hydroxide than at the beginning of the experiment. So result of these indicate that the periodic irrigation can potentially leach salt into shallow groundwater or into surface water via tine drains. During periodic flow interruption, the concentration of trace element rose again above the permissible WHO threshold, implying that the first irrigation event may be marked by elevated trace element concentration elution. That this is due to back diffusion from the immobile porosity fraction, okay, for specialists. And similarly, the dosage of sodium chloride to replicate evapoconcentrated solute flush from topsoil or from the below ground was characterized by significant trace element release due to sodium cation exchange with other major ions and trace element. Finally, additionally, we have a relatively high concentration of trace element that were observed in sample with abundant sedimentary organic matter fragment, which align with the previous finding that I show you of Abakaramu Makumu et al., alongside symptoms of pyrite and arsenic pyrite oxidation. Let's go for the take-home message. So we still have a few minutes for question if you want. So what I show you today was about the problem we have because salinity from reclaimed lands in coastal deltaic area is of upcoming concern throughout the world, not only in the potable delta, due to the ongoing climatic change and the associated water resources overexploitation. Understanding the origin of groundwater and the salinization process is pivotal to better manage this complex environment. Think about that if you believe that all of the salt water is just actual seawater intrusion, you would like to put a kind of a barrier along the boundary or the coast. But this is not absolutely not limiting the upconing of the paleo seawater intrusion. So you waste a lot of money and you have little result in the end. While multidisciplinary approaches involving, in this case, hydrology, hydrogeology, hydrochemistry, geochemistry, and biochemistry are not only necessary but compulsory. Otherwise, you just grasp a little tiny piece of this complex environment. Numerical modeling can help to bridge the gap among different scales from lab to field. And finally, the salts, nutrients, and trace element stored in this buried peaty layer can be a game changer in the context of the ongoing climate change. Why? Because they can release for long term a lot of unwanted chemicals that could be detrimental for many of the cropped species or the, let's say, ecological restoration of this environment. Okay, I have finished. So if you want to have more detail, you can visit our website for the nitrate excess print 2022 project we have developed because it's just finishing this month. So we are just delineate the final results. And this is all. It's just, I hope I'm in time because it's 10 minutes left before 3.
It's perfect time, Nicolò. It's perfect timing. Thank you very much for the very interesting seminar. I am no geologist, but I really followed it up with a lot of interest. And if you don't mind, I have a couple of curiosities to ask you, but I give priority to people in the audience if there are any that would like to ask any question, curiosity. Se ci sono domande e curiosità, per favore, o potete alzare la mano o prendere la parola direttamente. Abbiamo ancora qualche minuto con Nicolò con noi. Io nel caso, mentre maybe for continuiamo in inglese, penso we can continue in English. I mean, the talk was in English. So I have a curiosity on your first part of the talk, mid part and last part. So let's start with the first one. I've noticed that you have traveled quite a bit, between universities, institutions. You got 2 PhDs. That it's pretty unique. So I was just wondering if, from a personal perspective, if there is anything you want to share about challenges, about opportunities that comes along with an academic career that often requires to move across cities, and how difficult it can be, but if it pays off, if you have any advice to share with the students or the younger crowd that is in the audience. This is the first one. Then the second one, it's maybe just because of my real ignorance on the topic. I always imagine that water would move along salinity gradients. Well, instead, it looks like from the mid part of your talk that it stratifies, and you can actually age the water in the different layers based on the chemical content. And there was like kind of a revelation that it says a lot about how much we don't know, but what other colleagues do. And then the last but not least is about interdisciplinarity. If you have anything to, I don't know, to share with us about the, again, challenges, because the opportunities are clear, but the challenges of interdisciplinarity, of working at the onset between different disciplines and speaking. Did you hear, or there was a breakup in the connection?
There was a breakup. I almost grasped.
Interdisciplinarity, that's it. I thought it was very interesting how you ended your talk. And if you want to tell us something about the challenges, because opportunities are clear, right? So you showed us how much you can do when you cross disciplines. But if you have anything to suggest for people like me that are struggling with the challenges, if you have any tip for us.
Okay, thank you very much indeed for your questions. I will try to respond for the first one. Okay, for sure, traveling is challenging. It is extremely complicated, especially in Italy. Whenever you are taking a train, you never know where you ended up, or I mean, what would be the earthquake you've been stopping to, or any, I don't know what. Anyway, the point is that I was really convinced since the beginning, even if I spent 22 years as a non-permanent position, that research is super nice. I like it. I always try to do research, and I like it once again. So for me, it's a pleasure and a kind of a continuous game. Okay, it's like being a child in the kindergarten. The idea is that whenever I also have a family, I have a child, and I was not that old, so actually he's 20. So it was extremely complicated to get things going on. It is also rewarding because I would say I didn't stop at the beginning. So whenever I take the first no, you cannot do it because there is no money, I was just searching, me and my wife. Okay, we share the same path, let's say, and she's in another university, but both we started with this conviction that at the end we will make it through, and this is just perseverance, I would say. We are like a rover in Mars. Perseverance, just go, keep on and on. And one of the most challenging things is getting a salary, because just speaking clearly, it's not always that you can do whatever you like, and that's why I move around discipline. Okay, uh, but whenever you can find a logic along it, okay, and it's not quantum computing, that clearly is not my subject, but is something that can be dealt with. So the second PhD is just okay. Many people have double degree, and some can also have another PhD, just because it was already I was already old enough, okay, to get only the good out of it. I mean, only the nice stuff, that was making paper and making possibly new finding and having nice results to share. And this is essentially what is still now, okay, moving, and try to put a lot of effort to make new generation enjoy this kind of I would say serendipity. So whenever you instead of trying to complain because there's always things that are not going, trying to smile and go on. It's not easy, but this is the way it can go through. I mean, for my, that is almost mid generation, for the new generation, because they have a new challenge. The new challenge is artificial intelligence, that everything can be done with this, and also student can be bypassed because professor now can use artificial intelligence instead of students, and student can use artificial intelligence instead of going for class or understanding things. But we need to use our brain. This is the good stuff, and we still need to use it. Okay, so new challenges are always upcoming. The second question was about the salinity gradient, or chemical gradient you can find in an aquifer, and this is the big trick. I mean, the big trick is that one thinks that an aquifer is a kind of homogeneous stuff, like, okay, one concentration, and representative of the whole body. But in reality, an aquifer is like a stomach and can digest, okay, using the thermodynamic ladder. It is using oxygen, nitrate, and then manganese, iron, sulfate, and producing methane. And also, it's always slow because the water in surface can, I don't know, take 2 days from Mount Blanc to the Adriatic Sea, but in groundwater, it can take 2,000 years or 5,000 years or 10,000 years. So you have to measure it because it's a little bit complicated. So today I take it as simple as I can, even if I know that there was a lot of numbers and a lot of concept, but it is complicated. And this is why the third question, you cannot be Mr. Know-it-all. I mean, you cannot pretend to understand everything. So you need to go with other researcher for other disciplines, and the burden is nomenclature, because you usually we can say the same concept using different words. Okay, so whenever we understand each other with similar nomenclature, I mean, from discipline, from chemistry, or for botany, or for ecology, it takes a while, okay, to get acquainted among different nomenclature, but then again, perseverance is the same, okay, because after that, and you will be much happier, because if you do it in group, then it's always better, because the result is always, there's not anymore Lagrange or Einstein. There is a huge amount of people now working in the IPCC or in the accelerators. So this is the point. But you must enjoy what you're doing, and this is essentially research for
I
me.
think
I mean,
you said it all. I think that's the perfect way you ended up. Like perseverance, join what you find a path in serendipity, collaborate. I hope that the young students can hear this opinion and just remember these words, because it says a lot about how then success happens. So
I would say that when you reach half a century, then everybody is becoming philosophers. That's anyway. I'm sorry to bother you, because now it's 1 minute after 15, and probably people is fully digesting their meal.
uh,
So I don't know if you want to close.
Cambio lingua, passiamo in italiano. Ricordare solo a chi è in ascolto, per favore, di cliccare sul link che trovate nella pagina dei commenti per una valutazione del seminario di oggi, che ovviamente non è una valutazione nel contenuto, ma è una valutazione nella forma. Ci aiuta a noi di anno in anno nel modificare il formato, sempre per renderlo più digeribile, accessibile, ma anche interessante all'audience. Dall'anno scorso a quest'anno abbiamo cambiato tanto proprio in funzione dei commenti ricevuti, quindi è una cosa, ci vuole un attimo, però in realtà per noi è molto importante. Però con questo volevo ringraziare davvero Nicolò, Chiara e Vincenzo che l'hanno invitato, perché porti una prospettiva importante sia di esperienza professionale sia di contenuti per il Dipartimento, per tutte le persone che ci hanno seguito e che potranno seguire a partire da domani la differita su YouTube. Quindi se ve lo siete perso non è la fine del mondo, lo potete ascoltare di nuovo.